Good morning. Here we will solve some numericals that will be on the signal to noise ratio. In previous session we have seen about the signal to noise ratio and we have seen some numericals also. We will see again some numericals. What we are saying about the signal to noise ratio? It will be the ratio of normalized signal power with respect to the normalized noise power. We can say normalized signal power that we can take as a capital P, and normalized noise power we can calculate that will be equal to delta square by 12. Delta is nothing but it is the step size. But if the value of step size is not given at that time, we are having the formula for the Q. Q is nothing but the quantization level. We are having Q equal to 2 raised to V. V is nothing but number of bits. These are nothing but the digital bit. So you are taking Q equal to 2 raised to V. So now our del square upon 12 that will become del will become 2x max upon 2 raised to 2v. It means what? The maximum amplitude we are taking. So here if we are talking about the delta square by 12, you will get 2x max square upon 2 raised to 2v. So here now our equation for the signal to noise ratio is becoming 3 into normalized signal power P upon x max square into 2 raised to 2v. So here if we are having the question like suppose we want maximum error they have given 0.5% MP. So you can take 0.5 upon 100 into MP. You can take that is the maximum error. And here what they are saying for the 3 kilohertz signal. So it means what? F max is 3 kilohertz. So according to sampling rate, Fs will be 2F max. So 2 into 3 kilohertz. So you will get sampling rate Fs, or you can say here Rn, that will be 2 into 3 kilohertz. So you will get 6000 hertz, or we can say 6 kilohertz. And when we are supposed to find about the L, what bandwidth is needed to transmit the PCM, because this is the question. So here we are saying we are having the equation MP equal to delta V into L upon 2. So you can reconvert that equation and you can write delta V upon 2 equal to MP by L. We are having the MP value, delta V value. What is it? They have given. Suppose we want maximum error 0.5% MP. So you can write that 0.5 into MP upon 100. If you solve this, you will get L value that will be equal to 200. So that will be less than 2 raised to 8. So because 2 raised to 8 you will have 256. So you can take L equal to 200. So here now we are having the Nyquist rate. At Nyquist rate you will get signal frequency, or you can take Rn, that will be equal to 6 kilohertz. Now when we require 6 kilohertz into 8, because we are having L equal to 2 raised to V. So we will require, V is nothing but the number of bits. We will require 8 bit. So you can take V into Fs. That will give us sampling rate. Signaling rate. Sampling rate nahi, signaling rate. We are having the formula. R equal to V into F of S. V is 8. F of S we are having. F of S we are taking here Rn. That is nothing but we are taking as a sampling frequency. So you can take 6000 into 8 means V into F of S. That will be R, signaling rate. So you will get that will be the 48,000 bit per second. Now if we are saying a band limited signal can convey 2 symbols per hertz. So we are saying for the binary. So for binary we will need it half of that. So you can take 48,000 divided by 2. You will get 24 kilohertz. So for practical reason we are saying we sample faster than the Nyquist rate. Example, at rate 4000 hertz the required bandwidth is only 32 kilohertz. Again if you see here what we are saying about the signal to noise ratio, that will be the ratio of average signal power with the average noise power. We are taking for uniform quantization average signal power that will be equal to 1 by 2 MP square, or you can take A MP square, because we are taking approximate A value that will be equal to 1 by 2. And we are having quantization error. We have solved this. Already we have seen this concept. Quantization error, we are having 1 by 3, or you can take inside 1 by 12 in the bracket. So you can take here 1 by 3, because we are talking about the quantization error. That is nothing but, you will get quantization error. You have taken 2x max upon 2 raised to v square upon 12. But here we are now saying 1 by 3 in bracket mp by L square. L is nothing but, here we are taking the quantization level. Instead of Q, here we are using L. And instead of V, we are using here M. Don't confuse. Because if we are studying in the different PDF, they will use the different word. So here we can see we are having the formula for the quantization error, that is 1 by 3 MP by L square. But we are saying if signal to noise ratio will be equal to L square, because we are taking that will have a constant, that is the C. So you can take L equal to, you can take, that is nothing but 2 raised to V. But here you are supposed to take square of that. So you can take 2 raised to 2M. Because here we are taking the square. But here we are saying, if we are supposed to take that SNR value in the dB, you can take that like 10 log 10 of that value. We are having C into 2 raised to 2M. If we are taking C as a constant, we will have 2 raised to 2M. So you can take SNR dB, that will be 10 raised to 10 C 2 raised to 2M. So you can take for C, and you can take for that 2. If you are taking 2 raised to 2M, so 2M will get in the multiplication. When we are taking the log, these things you will get, because you are aware about how to take the logarithmic and the decimal value. So you will get 10 raised to 10 log of 10 C plus 2M log of 10 of 2. But here if we are taking that value, you can take alpha plus 6M. That will be the dB. Alpha is nothing but, it is the constant. How will you get? You will get from 10 log 10 C. So your equation is becoming here, because here you will get 2M into 2. 2M into 3, that is nothing but 6. So you can take alpha plus 6M. So here you will get alpha is nothing but 10 log 10 C. So if you are having any equation, you can see here, because these things you will be needed, how we are taking alpha plus 6 dB. So if we will see two cases for the 4 kilohertz bandwidth signal, L equal to 64 and M equal to 6 bits. So here SNR will become alpha plus 6 into M. M we are having 6. 6 into 6, 36. So you can take alpha plus 36 dB. For 256, L equal to 256. L is nothing but Q. Q is nothing but Q equal to 2 raised to M. 2 raised to M is 2 raised to 8, you will get 256. So here alpha plus 6M. 6 into 8, you will become 48. So you can write SNR dB equal to alpha plus 48 dB. So here when we have gained 12 dB in SNR, where PCM bandwidth has increased, you can take 2 into that frequency 4 kilohertz into 6 bit per twice, equal to 24 kilobit per second. If you solve this, you will get, we only need 1 by 3 greater bandwidth for 12 dB improvement in SNR. We will see remaining things in the next session. Thank you.